Hybrid search sounds simple until the alpha value quietly decides what your RAG system can and cannot find. We'll tune Weaviate in Python and measure recall instead of guessing. This is the workflow you'll know how to run when we're done, which tunes the hybrid weight and retrieves the supporting documents with that blend. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Hybrid search solves a practical problem. You need exact keyword hits and semantic matches at the same time. In RAG, missing a supporting fact can break the whole answer, so the retriever must reliably hand the generator the right context. Weaviate is handy here because it stores vectors and also supports keyword signals, letting you mix sparse and dense scores in one place instead of gluing two systems together. Think of alpha as a mixing knob. At 0, the system favors literal keyword matches. At 1, it leans entirely on semantic similarity from embeddings. If your users type precise phrases, a low alpha protects those exact hits. If they ask conceptual or fuzzy queries, a higher alpha surfaces meaning. We'll use a compact dataset so the effects are easy to see. Stage documents, run hybrid queries, sweep alpha values, and pick the blend that maximizes recall. We'll set up a small, repeatable RAG experiment. It stages a few illustrative sentences, adds a couple of incident logs to stress the system, compares pure keyword against pure vector retrieval, sweeps alpha to measure recall, and then runs a tuned retrieval that could feed a downstream generator. The goal is concrete, measurable tuning before you scale. Now we will create the collection and stage some toy documents. This snippet bootstraps a local Weaviate collection with a hybrid-ready text toy set. The import connects to the running instance through connect to local, which returns the client reused later. It provisions the hybrid docs collection using a single content property, so both sparse and dense signals live in one field. A brief batch list holds contrasting descriptions to mimic dense versus keyword retrieval queues before insert many pushes them into the index. The print confirms how many objects were staged, signaling the dataset is ready for subsequent hybrid queries. This step is important because hybrid search needs both a keyword index state and vector embeddings to fuse. Next, we'll add a couple of incident narratives and check how Weaviate fuses the signals by default. This example enriches the dataset and inspects Weaviate's default hybrid fusion response. It appends 2 incident narratives to hybrid docs, introducing both semantic context and explicit keywords that will stress dense and sparse retrieval. The docs query.hybrid call issues a single search for refund portal outage, while requesting metadata query score equals true. So each object returns its blended score. A short list comprehension pairs the sentence with its fused score, giving engineers a quick glimpse at how the two signals combine. Raising the limit would expose additional candidates, which is useful when you want to observe how quickly the ranking quality decays and whether relevant context falls out of the top results. Now we'll compare the two retrieval extremes to see how different they look. This code contrasts the retrieval extremes by dialing Weaviate's hybrid alpha to opposite ends. Requesting alpha equals 0.0 keeps only the BM25 ranking, so keyword top trims the leading keyword-heavy string for quick inspection. Another call with alpha equals 1.0 leans entirely on the vector index, yielding vector top and showing the semantic alternative. The tuple assigned to eval pairs records 2 evaluation prompts, plus the substrings that signal success, and the strings are truncated to 20 characters purely for readability. The printed pair makes the divergence obvious, underscoring why alpha tuning matters for balanced recall when you need both literal and conceptual coverage. Next up, sweep alpha values and measure recall across a small eval set. This snippet iterates through candidate alpha weights to quantify how the hybrid blend affects recall. Inside the loop, it issues Weaviate hybrid queries for every query marker stored in eval pairs and collects the returned objects. Each pass checks whether the expected substring appears among the top 2 results, accumulating hits that feed into the scores list of alpha recall tuples. Because higher alpha values emphasize semantic similarity and lower values defend literal matches, the balance directly changes how many prompts hit their targets. The final print summarizes the recall sweep, so you can spot which alpha performed best and choose a weight for the retriever stage. Finally, we pick the best alpha and run a tuned retrieval that would power a RAG step. This example promotes the recall scan into a tiny RAG decision. It finds the highest scoring tuple in scores, pulls out the alpha, and stores the user's recovery question for reuse. A fresh docs query hybrid call then runs with that tuned weight and returns the best context sentence, which is trimmed to 48 characters to keep on-screen output concise. That context string can feed a downstream generator or template, but appearing beside the alpha makes it clear which retrieval blended supplied the answer. The printed summary confirms that alpha tuning now guides the retrieval stage of the RAG workflow and supplies the chosen context to the generator. In a real system, map these toy docs to your logs or knowledge base and run the same sweep so the chosen alpha generalizes. Keep your evaluation set representative and record latency and top K behavior as you scale to trade recall against response time. Recap: hybrid search mixes keywords and embeddings, so you don't have to choose between literal matches and semantic recall. Use hybrid retrieval when queries blend precise terms and broader intent, and when missing a supporting fact would break the downstream answer. One caveat: the optimal alpha depends on your content and query patterns, so a single toy sweep won't guarantee perfection in production. Next step: tune the hybrid alpha on a larger validation set and add timing and accuracy checks to trade recall for latency. If short practical AI engineering helps, subscribe and watch the AI engineering videos.